Yes, we are back. All right. Welcome back to Galant Tutors Academy. So for today's video, we'll be treating questions on vector addition. Right? If this is the first video, if you're just watching this video, then I suggest you refer back to our previous video where I explain the concepts, at least the basics of vector addition. Right? And I also failed to mention one last case study, right, which we'll be doing today. So case 6, how are we going to find the resultant when we have forces, when we have more than two forces? Because all what we've been mentioning before is more or less like two forces. Yeah, just what we've been dealing with is just two forces. So let's read something. So you can see a question like this. Right, so let's assume this is F1. This is your positive x-axis. This is F2. This is what? F3. This is F4. What will here be? Negative x-axis, positive y-axis, and negative x-axis. So here we have a total of 4 forces, right? This is 1, 2, 3, and 4. We have a total of 4 forces. Okay, so how can we resolve this? How can we get the resultant? You remember when we are treating questions on perpendicular forces, if it's something like this, we can just say this is the resultant. I hope you remember. But for this, how are we going to represent the resultant? First of all, we have to take it back, right? We have to take it back to what? Perpendicular forces. We have to resolve it, right? Using physics terms, we will say resolve. We have to resolve it into x-axis and into y-axis. That's what we expected to do first, right? I will take it little by little, step by step, right, so that no one is lost. Okay, there is an angle here, right? There's also an angle here. I can say this theta 2, theta 3, right? This theta 4, right? Theta 3, right? And this theta 4. So I can actually represent it this way. Good? Alright, so after that, let's start from this. We're going to resolve into horizontal and what? Into vertical. Horizontal and vertical, horizontal and vertical. So let me just put it together so that you can follow through. Okay, so before we move on, I want to tell you something. So let's assume we have a theta here, and I want to resolve this. Let's say this r. I want to resolve it to the x-axis. What am I expected to do? What do you think I should do? Okay. I think I mentioned it in our previous class when I said SOHCAHTOA or something like that, if you can remember. Okay, so now we have the hypotenuse, we have the adjacent. So we have hypotenuse and adjacent. So that means simply we are going to make use of cos. So cos theta is equal to what? Adjacent, which is what? This. So let's assume this is y. This is an arbitrary value, so this is y over r. So you will notice that something similar occurs in all this, right? That is, when we are resolving to the horizontal, right? When we are resolving to the horizontal, we usually use cos, and when we are resolving to the vertical, we actually use what? Sine. But there is always a criteria you have to pay attention to. The theta or the angle must be towards the horizontal. Do you get that? Must be towards the horizontal. Okay, let me take this for example. Okay, okay, let me just do it in the second page so we don't waste space. Okay, so let's assume I have something like this. I get in. Okay, something like this now. All right, so this x, this y, and this r, right? So if I want to resolve this to the vertical, like if I want to resolve this, right, to this part, what do you think I am expected to do? First of all, we are not changing the theta, right? We are leaving it this way, right? So I can actually connect here. Since this angle and this angle is expected to be the same thing. So this is theta and this is 90 degree, right? If this is 45 degree, then here will also be 45 degree. This is 45 degree, right? This is also 45 degrees, something like that, right? Something similar. But I'm not trying to place confusion. So we have something like this now. X, Y, and R. So if I want to resolve these to the vertical, what will I do? These we have hypotenuse here, that is the R. Okay, so we have our Y, because we want to resolve it to this part. So how is our Y? Our Y is actually opposite our theta. So Y is opposite. Exactly, Y is opposite. So remember SOHCAHTOA, which is sine theta, opposite is what? Y over R. Now look at this, sine instead of cos. Do you get that? Sine instead of what? Cos. So you have to take note of it, that whenever the theta is not towards the horizontal, we are not going to use what? Cos theta. I get it. It will be what? Sine theta. I'm just trying to just establish it. Do you get? Alright. So now let's go back to what we're doing. Okay, so for the horizontal, if we want to resolve these to the vertical, what will it be? To the horizontal, I mean to say, right? This horizontal, this vertical. So it will be plus f1 cos, this one, sorry, this one, cos theta 1. That's for f1. Now if I want to resolve it to the vertical, don't waste the strength, just plus f1 sine theta 1. Exactly. Good. For the second one, which is f2, is going towards this side, right? This came here and came so like this is going towards this part, which is positive. So we are going to have plus, since the theta is towards the horizontal part, this is the horizontal part, since the theta is towards the horizontal part, cos will still retain, right? We're still going to use cos, so we're going to say cos theta 2. Right now, this, remember the sign, so instead of plus it will be what? Minus f2 sine theta 2. Exactly. All right, so all of f3, this and this, both sides will be negative. Can you see the both sides will be negative? So we have minus minus f3, right, cos theta 3, right? This will be minus f3 sine theta 3. The next one, which is f4, this is negative and this is positive. So for the for horizontal, it will be negative, so it will be minus f4 cos theta 4 and plus f4 sine theta 4. Right, can we cross check what we're going to do, what we did to ensure it's correct? We all know that cos is correct, sine is correct. So the sign now, this subtraction, this plus, this plus, correct? So we have for the F2 we have, for the horizontal we have positive, correct? For the vertical we have negative, correct? F3 we have both negative, correct? F4 we have only the horizontal being negative. All right, so this is the first step, right? So we've been able to resolve it, right, into vertical component, right, and a horizontal component. Is that clear? All right, so so from here what we're going to do is that x, which is this x, this can be x, this is also y. So all what is under x, we're going to sum it up. So summation x, I get in. So we have f1 cos theta 1 plus f2 cos theta 2 plus minus, plus times minus is what? Minus. So minus will come out. So minus f3 cos theta 3 minus f4 cos theta 4. Is that clear? Alright, so summation y is equal to f1 sine theta 1 minus f2 sine. I'm adding all this, so don't be confused. I'm adding all this, right? So sine theta 2 minus f3 sine theta 3 plus f4 sine theta 4. Is that clear? So now, if in a real scenario, in a real question, all these forces which are represented as F1, F2, F3, we have a specific value. We have a specific what? Value. And also, some external exam don't give calculator, or the calculator they provide are not able to perform certain functions, right? They're able to perform certain functions. So I want you to note something. If a vector is directly aligned, so like let's assume this x-axis, right? And a vector, a vector is just like this, just parallel to it. If a vector is directly aligned with the x-axis, its angle of inclination is 0. Its angle of inclination is 0. In contrast, if a vector is directly aligned with the y-axis, so let's assume this is the y-axis, right? And we have a vector quantity, right, that is directly aligned with it, right? This is what? The angle of inclination is what? 90 degree. How do we know it's 90 degree? Because we take reference from what? The x-axis. We take reference from what? The x-axis. Is that clear? So like, what does this look like? 90 degree. But now how are you going to describe this? Nothing. Is that clear? Is that clear? Alright, so I said some external exam do not give scientific calculator, right? So there are certain trigonometry functions, right, that you should know. Trigonometry ratios that you should know. There's a way to prove it, but I won't be doing that in this video, right? I will probably in the nearby future I'll create video for that, right? So tan 60 is equal to root 3, right? Root 3 is what? 1.73. Is that clear? Good. So sine 60 is equal to, is the same thing as, sine 60 is the same thing as cos 30. Now for the smart student, sine 30 will be the same thing as what? Cos 60. Correct. So sine 60 is what? Root 3 over 2, which is 0.87. While cos 60 or sine 30 is very common, is what? 1 over 2, or we'll say 0.5. And lastly, tan 30 is equal to what? 1 over root 3. 1 over root 3, which is what? 0.58. Is this clear? Is this clear? I hope it's very clear. Alright, so let's move to the next one. Okay, so for today's video, right, I will be treating questions or problems on two cases. One is two forces parallel to each other, right? And the next one is two forces acting perpendicular to each other. Two forces acting perpendicular to each other. Then I will do a brief recap, maybe some of the things I feel you guys might have forgotten, right? And then give you home tasks. Is that clear? So this is the outline for today's video. All right. So for the first question, it reads: a lorry travels 10 kilometers northwards, 4 kilometers eastwards, 6 kilometers southwards, and 4 kilometers westwards. So these are the key words we have to take note of, right? Okay, I hope you all know cardinal points. I'm very sure everyone watching this video now knows what cardinal point. But if you don't know, don't worry, you will learn it now, right? So this is west. W here stands for west. The E here stands for east. Here stands for north, and here stands for south. So these are the four cardinal points we have. Is that clear? Good. So let's represent it. So we have northward. What's northward? This is northward, isn't it? So we have 10 kilometers here. I'm referring to this. Is that clear? So now 4 kilometers eastwards. 4 kilometers eastwards. So 6 kilometers southwards. Are you there? And lastly, we have 4 kilometers west, 4 kilometers westwards. So this is the diagrammatic representation of this question, right? Of this question. And now remember, they said it arrived at point C. We'll come to that, don't worry. Do you get? So now I want you to pause this video, right? Pause this video and try something on your own, then come back for the correction. All right, welcome. So 4 kilometers. What I tell you when forces are opposite each other, can you remember? They are going to be subtract. You are going to subtract it. So if we have 6 here and we have 3 here, it will be 6 minus 3, which will go towards 3. So for this we have 4 kilometers minus 4 kilometers, which is what? 0. So for the horizontal, the resultant is 0. So let's focus on the vertical. All right. So we have 10 kilometers. Remember, it's moving in this direction. Okay. So we have 10 kilometers here, and we have 6 kilometers here. What are we going to do? The same thing. 10 kilometers minus 6 kilometers, which is what? 4 kilometers. Is that clear? 4 kilometers. Now, where will you be pointing to? Remember that displacement is actually a what? A vector quantity. So whenever we say something, we must also specify its direction. So where is this pointing to? This is 6 kilometers, this is 10 kilometers. So definitely it's pointing what? Northward. So we're going to say for the displacement is at 4 kilometers northwards. Is this clear? Is this clear? I'll come over it again. Now, in the horizontal direction, this is horizontal, right? So don't forget it. This is vertical, this is horizontal, this is vertical. Don't forget. The red is vertical, green is horizontal. Okay, so for this part, we have 4 kilometer minus 4 kilometer, which will give us what? 0. For vertical, we have 10 minus 6, which will give us what? 4. Now, which is big, which is more, which has more magnitude? The one moving towards the north, towards northward, right? Towards the north. You get, so which is what? 4 kilometer. Is that clear? So since it's displacement we're talking about, which is a vector quantity, we have to specify its direction. That's why I said northward, right? If it was distance now, it will be a different case. All right. Okay. So question 2. We have 2 forces act eastward and westward, respectively. So this is west and this is eastward. So we have 2 forces acting in this direction and acting in this direction. Okay, for the one acting towards the west direction, since they say respectively, this will be for this, right? And this will be for this. Is that clear? So now for westward we have 8 Newton, and for eastward we have 6 Newton. Is that clear? Now the same principle applies. Whenever 2 forces are moving in opposite direction, what do? Subtract. If they are moving in same direction, you add. All right. So 8 Newton minus 6 Newton will give us what? 2 Newton. Is that clear? 2 Newton. No stress. Now we are not going to stop here. If we stop here, the lecturer or the examiner will fill it for us. What's the direction? 2 Newton towards the west, or you just say westward. Anyone is acceptable. Okay, but look, there's something very peculiar here. Equilibrant, not resultant. Now, equilibrant and resultant are more or less like brothers, right? They are almost the same thing, but they differ in something, right? This direction, they differ in direction. Like now, this answer I just gave you now is for what? Resultant, right? If I want to specify for equilibrant, I'll have to what? Give the opposite of westward, which is what? East, towards the east. It will be towards the east, or what? Eastward. So equilibrant, right, has equal magnitude as the resultant, but is opposite in direction. So this is what you have to note in equilibrant, in case you see it somewhere. So we have equilibrant has equal magnitude as resultant, right? But opposite in direction. Please take note of this, very important. So now if I want to represent the one for equilibrant, what will I say? It will be 2 Newton eastward. Is that clear? All right. So this is what for resultant. This is for what? Equilibrant. Okay, to the next question. 2 forces, 9 Newton and 7 Newton, act northward and southward respectively on a body. Calculate the magnitude of their resultant. Now, they said magnitude of their resultant. So in this scenario, we don't need the direction. We don't need to know the direction, right? I just stated the direction in previous one in case of some certain questions which you're going to encounter in external examinations. Is that clear? But now, if they tell you what is the magnitude of their resultant, you shouldn't specify a direction. Is that clear? Good. So pause the video and solve this. This is very simple, and every one of you should get the answer. Once you get the answer, comment in the comment section. Right? Say it in the comment section. So we have northward as 7 Newton, and we have southward as northward as 9 Newton, sorry, and southward as 7 Newton. Is that clear? So the same principle, subtract, is nothing hard. So 9 Newton minus 7 Newton is what? 2 Newton. Is that clear? 2 Newton. Good. Okay. So after that, where is it pointing towards? It's going towards what? The north. So northward. But this is not our answer. The answer for this is what? 2 Newton. Really? 2 Newton. No stress. Okay. Now let's go into more little bit complicated questions. Good. Okay, so a tugboat is traveling from Asaba to Onitsha across a river. So it's more likely that Onitsha is here and Asaba is here, right? Since they said the waters they cross the river. Look at it here. They said a tugboat is traveling from Asaba to Onitsha, right? Across the river Niger, right? With a velocity of 20 knots. So the velocity of these is 20 knots. If the river is flowing at 12 knots, the direction of the motion of the boat relative to the direction of water flow is what? Now, I'm going to explain this part for you, right? This last statement, so you get what I mean. Okay, first let's reconstruct this so it's easier to understand, right? So we have 20 knots and we have 12 knots. Good. So this is how the resultant will be. You know that by now. This is the resultant, right? Good. So now they said the direction of the motion of the boat relative the direction of this the motion direction of the motion of the boat. Is that clear? Related to the direction of water flow. This water flow. So what's this telling you? The angle between them, which is what? This. Is that clear? The angle between them, which is what? Angle theta. Good. So now let's solve for it. This is what I'm looking for, right? Good. If it's 20 knots, this is also 20 knots. I told you that opposite sides are equal. So let's bring it out. So we have this. We have 12 knots. And we have R and theta. Exactly. Okay. So we don't need the R actually because we're not told to find the resultant but the direction. We're told to find the direction alone. So now this is opposite and this is adjacent. So remember Secatwa. So we have Secatwa, which is adjacent, right? This is adjacent, right? And adjacent and opposite and adjacent. Exactly. 20 is opposite, 12 is adjacent. Alright, so from here we're going to use what? Which formula we're going to make use of? We have opposite and adjacent. Tan, of course. So we have tan theta is equal to opposite, which is 20 over 12. Is that clear? So theta will be what? Tan inverse of 20 over 12. So this should be your answer after making use of the calculator. Is that clear? So first of all, try solving it and tell me your answer. Alright, question 5. Two forces whose resultant is 100 Newton are at right angle to each other. They are at right angle to each other. The resultant we know is 100 Newton, right? If one of them makes an angle of 30 degrees, so let's assume this is the angle and this is the R, this is the F1, which made an angle of 30 degrees with the resultant. When I'm asked to determine the magnitude of this force, so they're asking us, hello physicists, what is the magnitude of F1? Okay, this is very straightforward. This is what? Hypotenuse. This is adjacent. Adjacent hypotenuse, we have car, right? So cos theta is what? Adjacent, which is F1 over what? 100. Right? Remember that theta is what? 30. Right? F1 over 100. Right? So we have cos 30 times 100 is equal to F1. So what's the value for cos 30? Do you still remember? If in case you've forgotten. Cos 30 is what? Root 3 over 2. You shouldn't forget that. It should be within mind always. Okay, so we have root 3 over 2 times 100. 2 here 1, 2 here 50. Is that clear? So remember that root 3 is what? 1.73 times 50 is equal to F1. So using calculator, you should get the correct answer for this, right? I want you to be engaging with the question, with what I'm doing. That's why I'm not giving the final answer. So you should solve it and tell me what the correct answer is. Alright, so lastly, the last question for today. We have a body of mass 20 kg is set in motion by two forces at right angle to each other. Determine the magnitude of this acceleration. So now, write the parameters. Right, in such a question like this, write parameters. We need to find the acceleration. We don't know. We know the mass, which is 20 kg. Okay, so which formula connects mass and acceleration together? Definitely Newton's force, which is what? Ma. Is that clear? So now this F now, which is the force, we have two forces here. What do? We have to find the resultant force. We have to find the resultant force to get our acceleration. Now that's easy peasy. That's very simple to do. So we have two forces, which is 3 Newton, which should be 3 Newton and 4 Newton, right? So we have 3 Newton here and we have 4 Newton here. Is that clear? Okay, so just find the R. We're looking for the R. Okay, so these take this for your theta, opposite and what? Adjacent. Opposite and adjacent. Opposite and adjacent. So opposite and adjacent, right? So we have, we're not going to use opposite and adjacent, sorry that. We're going to use Pythagoras theorem, which is R square equals to 4 square plus 3 square, right? R square is equal to 16 plus 9. R squared is equal to 25. R is equal to what? 5. That's this, I got it. Square root of 25 will give us 5. So our R is what? 5. And remember that R is equal to FR. FR is equal to F. So this is resultant. This is the resultant force, and system is force, right? Equals to ME. So we have F is equal to our mass, which is 20 kg, right? Times A. Divided by 20. Divided by 20. So we have A equal to 5 here 1, 5 here what? 4. 1 divided by 4 is what? 0.25. What's the SI unit of acceleration? Meter per second square. I guess it. So these are final answer. Alright, your home tax. Your home tax. You have to submit it as soon. Immediately you see this, immediately you finish watching this video, just solve the question and submit. So there are two ways you can submit. You can send us, and you can send your answer, right? Your answer or your solution to our email address, which is officialgallant.tutors@gmail.com, right? Or just say the answer or drop the solution in the comment section below. Do you get that? Anyone that's convenient for you, right? We'll reply, and wherever you send it, we're going to reply. We're going to reply you. We find our delight, we find joy in serving our customers in the best way possible. So we've come to the end of this video. Now let's see what we've actually learned today. Okay, so we talked about forces when there are more than one force, when there are more than two forces. When resolving to the horizontal, use cos theta. When resolving to the vertical, use what? Sin theta. Exactly. Do you get that? And you should take note of where the theta is, because sometimes the examiner might intentionally place it toward the vertical and not toward the horizontal. So instead of resolving toward the horizontal as cos theta, you're resolving as what? Sin theta. Is that clear? So you should take note of tan theta equals to root 3 sin theta, tan 60 equals to root 3 sin 60 is the same thing as cos 60, which is equal to what? Root 3 over 2. Sin 30 is equals to sin 30 equals to cos 62, which is equal to what? 1 over 2, right? Tan 30 is equal to what? 1 over 3, right? That is this. Equal to 1 over 3, right? Please take note of it. Okay, so all these are normal questions which we've solved over and over, so you can go over it, right, and ensure that you don't fail anyone. Is that clear? All right. Thank you so much for being with us. Thank you so much for watching this video. We really appreciate it. Now, as I've always said, keep learning, never relent. Never relent. Keep learning. Try your best possible to change your society. Try your best possible to change your environment. Now, don't go yet. Subscribe. Good. Subscribe. Ensure you like this video and share to your lovely ones. Share to your friends. Share to your classmates. Right, so they can also benefit from this. Thank you so much. Good luck. Bye.